Okay, welcome to day 5. I will be back tomorrow, so I look forward to seeing everyone. So in this video, we're going to use compound interest formulas to solve a variety of problems. And remember, I told you that exponential functions can be used in banking, so we're going to see how that works today. So if you recall from Friday, exponential functions are in the form of y equals a times b to the x, where a is your initial amount, y is your final amount, and b is your common ratio. This is going to be the basis of the formula that we use to do growth and decay. So these functions are used in science, business, finance, and other areas. But we're going to start by looking at the basic growth and decay. So on your papers, if you would write down the formula for both growth and decay. The difference between growth and decay is that growth is plus r and decay is 1 minus r. If you need to pause this, go ahead and pause it while you write that down. Remember that y is our final amount, a is the initial amount, and r now, this is new. B is either 1 minus, the growth rate is 1 minus r or 1 minus b or 1 plus b, and this is where this formula comes from. So now we're going to be given a rate of increase. And to find that rate of increase, we're going to have to write it as a decimal. So if it's 5%, then we would write it as 0.05. And x is going to be the amount of time that has elapsed. Okay, so let's just do an example. So as you read the question, you need to determine whether or not it's growth or decay. So Mrs. Haynes invested $1,400 in an account that increases 9% each year. So from that, we can determine that we would use the growth formula because her account increases. So to write an exponential growth function to model this situation, we start with the formula. Well, let's talk about what we were given. So we are given an initial amount of $1,400. We're also given the rate. So we're given the rate as 0.09. And we're also given the time. So the time is 25 years. The question is, what are we looking for? Well, we're looking for y, the final amount. So we're going to use the growth formula. Notice that we did plus 0.09. Also notice that it said 9%, but we have to take that 9% and divide it by 100, or move the decimal 2 places to the left. So we have 14, 1 plus 0.09 raised to the x power, and in our case, x is 25. Now, you can just simply put this in your calculator exactly the way that it is. So in your calculator, what you would put in was 1,400 parenthesis 1 plus 0.09 close parenthesis caret 25, and you put that all in as one step. You do not have to separate it. Put it all in as one step if you have a graphing calculator, and it will give you a nice pretty answer. Let's look at the next example. So we have a population of Michigan, and it's decreasing at a rate of 3.75%. So if it's decreasing at that rate, do you think we're going to use growth or decay formula? That is correct. We're going to use the decay formula. So we're told that in 2000 there were 26,000 people. So 26,000 people are our initial amount. Our rate at which it's decreasing is 3.75%, but remember we have to move the decimal 2 places to the left, and that's going to give us 0.0375. Now our time, we're going to have to figure out the time here because we're told what it is in 2000 and we're trying to figure out what it is in 2016. So our time here is actually going to be 16 years. It's the difference between the two. So now let's write our equation. We have A is 26,000. We have our rate of 0.0375, and it's being raised to the x. In this case, x is 16, so we put that in, and then we go to our handy-dandy calculator and put in the formula, and we get 14,105. Now, one of the things you want to do is you want to make sure that your answer makes sense in context. So because we're using the decay formula, because it's decreasing, we would expect our answer to be less than $26,000. 26,000 people, and it is. Okay, this is what I like for you to do. I'd like for you to pause the video, and I'd like for you to try problems 3 and 4. Okay, welcome back. Hopefully you found an answer. And those are my answers. If you did not get that, check with one of your neighbors to see if there was something that you did incorrectly. All right, looking at problem 5. Problem 5 is a little different because now we're told the final amount. And we're trying to determine the initial amount. So Lindsay wants to have $5,000 in 5 years. And she finds a savings account somewhere that's paying 8.5%. And so she wants to know how much does she have to save today to have $5,000 in 5 years. So what are we given? A is our unknown. She doesn't know how much she needs to save. But we know R, and we know X, and we know Y. We know how much she wants to have. So let's set up our equation. Now, using your calculator, you can calculate 1 plus 0.085 raised to the 5th power. You can calculate that on your calculator, and it gives you that amount. And so to find A, we would divide both sides by 1.503. And so she needs to have at least about $3,325 today. She wants to have $5,000 in 5 years. Okay, next we're going to look at compounded interest. So yes, take a moment if you have to pause the video to write down the compounded interest formula. Now what you want to notice about all of these formulas is that your final amount is always what it's equal to, and what's outside the parenthesis is always the initial amount. So in this case we're calling it the principal. The rate is going to be the same as in the last problem. Now, N is the number of times it's compounded within the year. So if it's compounded quarterly, then there would be 4 times in the year. Semi-annually would be 2. Monthly would be 12, and daily would be 365. And in this case, T is always going to be in years. Okay, so let's say we're going to do problem 6A. Let's say we have $500 in an account, and it pays 9 cents annual interest, but it's compounded quarterly, and we want to know what is the balance after 3 years. So what are we given? We're given that the initial amount is $500. We're given a rate of 0.095. It's compounded quarterly, so that means N would equal to 4. And we want to do it for 3 years, so T is equal to 3. And we're trying to find A. So we plug and chug what we know. Now this is just a matter of putting it in your calculator. And as long as you put it in your calculator exactly the way that I have it written here, you should be fine. Just remember to put parentheses around 1 plus 0.095 divided by 4. Close those parentheses, put your caret, and then 4 times 3 in parentheses. And that gives us $662.67. Now we're going to do the same thing, but this time so everything remains the same except for N. N is now 12. And what you want to notice is that your amount at the end should be very similar. So the first time we got 662. We wouldn't expect this to be $1,000 more or less. It should be very close to what we got for quarterly. The more time it's compounded, the more it's going to be. So it's a little bit more than last time, but not significantly more. Let's do it for annually. Annually just means N is equal to 1, which actually is just the growth formula. When N is equal to 1, that's just the growth formula. Okay? Alrighty, let's do our next one. How much must you deposit? So this one's a little different because now I'm asking you, it's similar to the question with Lindsay's wedding. We want to know how much needs to be deposited in order to have a final amount of 5,000. So once again, we write down what we're given. This time we're given the final amount is 5,000. We're trying to find P. We're given the rate, and N, because it's compounded semi-annually, N is 2, and the number of years is 15 years. So let's plug and chug. Once again, I can calculate 1 plus 0.065 divided by 2 raised to the 30th power. I can calculate that on my calculator and I get a number. And then whatever number I get, I do 5,000 divided by that number to get 1915.44. Okay, so you try number 8. Pause the video and then I'll come back and give you the answers. Okay, hopefully you've done number 8. And here, so annually you have 2. So it's actually doubling. And then semi-annually, if it's compounded twice, you'd have $2.25. Quarterly, $2.44. Monthly, $2.61. Daily, $2.71. Hourly, $2.71. Notice that daily and hourly become very close. And if you did it every second, you also had to calculate how many seconds were in a year to do that as well, which could be a little challenging. All right, let's do continuously compounded. This is a new formula that you may not be as familiar with. A lot of people call it PERT. A, once again, is our final amount. P is the initial amount, the principal. R is the rate as a decimal. And T is time in years. Now, E is an approximate, it's an irrational number, just like pi. I call it pi's little sister. It's irrational. If you look on the bottom left of your calculator, above the LN button, there's an E to the X button. Locate that because that's what we're going to use to solve these problems. So go on the first row of your calculator, the first column, right above the number 4, it's a blue button right above natural log. That's the button that we're going to use to calculate that we're going to use for e to the x. Okay? So we're going to do the exact same thing we did a minute ago, but this time we're going to do compounded continuously. So we're trying to find A. Our principal is 1, R is 1, and T is 1. Now, once again, to do this on your calculator, use the E to the X button, which is right above the natural log button. And we get $2.71, 72 cents. And you'll see that that's very close to hourly, what we got for hourly. Okay, so let's do another problem. Find the balance compounded continuously at 6% after 25 years if $5,000 was originally deposited. Okay, so what were we given? Our initial amount, our final amount is what we're looking for. Our initial amount was 5,000. R is 0.06 and time is 25 years. So we just plug and chug. Okay, so now we're trying to, once again, to find P. Because we're asked how much must be deposited. So we're trying to figure out what is the initial amount that we started with, and we want to end up with $10,000 after 20 years. So we have A is 10,000, P is unknown, R is 0.105, because we have to move that decimal 2 places to the left, and T is 20 years. So once again, using my calculator, I would do e to the x and then 0.105 times 20. And that's going to give me a number. And then whatever that number is, I divide 10,000 by that number. So I'd have to deposit $1,224 in to get 10,000 after 20 years. Now this one's a little different. How long will it take it to double? A lot of times for these, because we're looking for t, and we're not going to solve logarithmic equations. So for today, I'm just going to let you guess and check. When I come back on tomorrow, I'm going to show you how to do it on your calculator. Okay? So we want to know how long will it take $500 to double. So if we started with 500 and it's doubling, our final amount is going to be 1,000. 2 times 500. So my principal is 500, my rate is 0.03, and I'm looking for t. So I set it up. So now what you can do is you can simply guess and check. So take values of t to get that 1,000. And we find that it takes approximately 23 years. There's another way of doing that I will show you tomorrow. That's it for today. So you should be able to identify if an exponential function is growing or decaying based on the graph and an equation. Find the growth rate given an equation. We did that on Friday. Use growth and decay to solve problems, and use compound interest and continuously compound interest formulas to solve problems. Your homework tonight is to finish problems 1 through 7 on that day. It says applications of exponential function practice. That is your homework, and you can work on that now as well. I would probably do a few problems before I try the online assessment. So remember, you also have to complete that online assessment by the end of today. So have a great day, and I will see you tomorrow.